Today I want to talk about the hybrid data lifecycle, and I'll get into what that really means because the title is a little bit misleading. My name is Sandeep Parikh. I run the Google Cloud Solutions Architecture team for America's East. What I want you to sort of think about and take away from this session is really understanding that data lives in multiple environments, right? It's not just on-premise, it's not just in cloud, it's kind of in both places. And even in on-premise scenarios, you might have sort of core infrastructure, you might have private cloud, you might have other virtualized infrastructure. The idea is that data is kind of spread out in a bunch of places. And what I want to do is kind of take that thought process, particularly from the on-premise perspective, and map that to what we sort of think of as the data lifecycle through 4 kind of applied scenarios or practical scenarios. Kind of as I said earlier when we opened, it's kind of a hybrid world, right? Whatever you want to call it, hybrid, heterogeneous, multi-cloud, you've got applications and infrastructure kind of spread out across a number of different environments, right? How many of you have a scenario kind of similar to this that you're running into at your own organizations? You've got multiple environments, you've got data spread out across different ones, each one is sort of satisfying different workloads. The problem is it's hard to kind of wrap your hands around all of these things in one place. So how do you kind of tackle those problems as it relates to things like processing big data or handling, large-scale ingest coming in from applications or from devices, right? That's the sort of stuff we want to try to unpack and figure out as best as possible. Why do you even consider going down this hybrid route? Like, why would you even look at this, right? Everything's great on-premise. We should just stay there forever. Let's never leave. But the reality is that there are a lot of challenges when you're in an on-prem environment, right? You've got things like maxed out resources. That means if you want to deploy new applications, if you want to deploy new features or functionality, you've got to pull those resources back from something else and perhaps pay a latency or a throughput penalty, right? That's not a great option. You might just have generic sort of compute limitations, right? People might have to wait in line to run big processing jobs and whatnot. And ultimately, what that sort of adds up to is sort of the third item, which is the time it takes to kind of get meaningful insight and understanding out of your data and deliver that back not only to the business but to your end customer is pretty long, right? And you're trying to get out of this cycle where you're bumping up against the ceiling of what you have access to, and you want to be able to get information and understanding back out to every part of the organization and again to your customers as quickly as possible. All right, so what are the approaches you could take? So the one that people always think we're going to tell them is just pick up everything, put it in a truck, and drive it over to GCP. And while that's perfectly fine if you really want to go down that road, it's not without its challenges, right? And I could trivialize a bunch of the details, but the reality is that that approach is really hard. If you try to pick all that stuff up today and move it to the cloud, you're going to have trouble, right? People are going to be unhappy, things are going to break. Ultimately, what might happen is you might drop data on the floor, you might build one-off migration processes that aren't going to scale over time. You're going to run into a lot of rough edges, and frankly, you're just not going to be happy. So instead of trying to say, let's move everything over, go whole hog right off the gate, instead, let's find ways to sort of bridge the gap. Right? Let's move certain workloads that make sense. Let's try to find an easy on-ramp and let the cloud be your place for scale, new applications, compelling functionality that you couldn't do because you're maxed out in on-premise scenarios. All right, so what is the data lifecycle, right? Or at least what do we think of the data lifecycle as? So it's basically 4 main steps, right? You've got ingest, and that's data coming out of applications, data coming out of devices, mobile applications, what have you. But that data is coming into your infrastructure in some meaningful way. So the first thing you're going to do is you're going to capture all that stuff, and you're going to store it somewhere. You might store that in a variety of databases. It could be anything to objects, log files into something like an object storage infrastructure. It could be relational data. It could be semi-structured and go into either key value, document, wide column database infrastructure. And then you've got to do something with that data, right? You want to actually churn through it all in some meaningful way and start extracting a little bit of value out of it. So you want to go through that step of processing all the data, joining things together, denormalizing things in some cases, and then analyzing it. And then you get to the last step where you get to really explore and visualize that data. And that's where you start generating that really sort of deep intelligence about what your organization is really doing. So if you take those kind of 4 steps and you map them onto 4 kind of what I call kind of practical scenarios that we talk about a lot with customers, what does that look like? So the first scenario is kind of basic, right? You've got on-prem relational infrastructure, but you need to kind of adopt a data warehouse approach, right? You need something that's going to let you scale out a lot. And it might not just be one database. And frankly, it probably isn't just one database. It's probably a dozen or so sort of disparate, kind of distinct sources of data, distinct data types, but you've got to put all that stuff together in order to get an understanding of your business from a number of different angles. So one is, again, moving on-prem relational to a data warehouse. And that's kind of under the sort of process phase and under the explore phase, right, of the data lifecycle. The next one is migrating Hadoop and Spark workloads to the cloud. Right? This is usually easy, low-hanging fruit for a lot of people because they can just pick up their jobs and move them somewhere else. But we're trivializing a pretty critical detail, which is those big data deployments on-premise usually have a lot of data. And it's not like you can turn off the sources of data one day, move everything, and turn them back on. It's that data is coming into the system on a regular basis. So you have to find a way to move everything once in one fell swoop and get that sort of ongoing incremental transfer to make sense. And that kind of falls under the sort of the process and analyze phase of the lifecycle. The other one I want to talk about is cloud applications plus on-prem data. Listen, I'll be honest with you. Not every data source, not every application, frankly, is a good fit for cloud. There's a lot of stuff that might have to stay on-prem for a variety of reasons. It could be compliance. It could be, sort of in-depth security concerns you might have. It could be, other business requirements that we might not even know about. But the idea is that there are some things that might have to stay there. So how do I enable development teams to deliver new features and functionality, right, to a wide variety of customers, but still having access to that data that sits on-prem? Right? How do I front that for them so they can go build something compelling while still not really upsetting the balance of what's here on-premise? So that's kind of in the ingest and store phase of the life cycle. And the last one is kind of the same thing, right, inside of the ingest and store phase. But think back to those kind of on-prem challenges where you're maxed out on resources. What if you have an insanely great, IoT idea tomorrow? You've got this compelling, hilariously compelling, connected light bulb, and you want to get these things out. You're talking about millions and millions of households with, 10, 20, 30 bulbs in there. That's a lot of data, right? That's a lot of events being generated. That's a lot of on and off switches that are controlling these things, that are pushing data through. You might not have enough infrastructure to actually take all that data in. So where's it going to go, right? You've got to put that stuff somewhere. But you've also got to remember to enable the business to learn from that, right? There might be internal applications, again, living on-prem, that need access to this data. So how do you kind of facilitate that sort of, kind of circuitous kind of life cycle there around where the data is going to go and how you get access to it? So those are the 4 workloads I kind of want to talk about a little bit in depth and how you sort of tackle each one of them. The important thing to remember is that in all these scenarios, you've got to be heterogeneous, hybrid, multi-cloud, whatever. You've got to be friendly to this concept, which means, and again, I'm not going to go through all this right now in this talk, but definitely come find me afterwards. There are a lot of concerns that are sort of at the foundation level there, right? Like how do you handle security? How do you handle governance, ownership? Who has identity and access control to all these things? Those are all really important things to think about, and it's critical that you work through those open items before you go down this road. Because once you do that, then you've opened the door to, to kind of scaling on both sides. But again, you've got to take on this sort of heterogeneous lifestyle approach to the world. And then frankly, you've got to have this thing be scalable, because otherwise, what's the point, right? If you can't scale it in a cloud environment or a public cloud, then this approach really isn't going to work in any of these cases. All right, so let's dig into each one of those practical scenarios and kind of walk through what they look like tactically. All right, so the first one is on-prem relational to cloud data warehouse. So it's really simple. Just do this, right? And that's it. The talk is done. No, I'm kidding. The idea is you've got to get database, and frankly, again, databases, but I didn't want to fill up too many icons on the slide, but you've got multiple databases. You want to get into something like BigQuery because you want to be able to do ad hoc SQL. You want to explore that data. You want to look at it, normalize and denormalize. You want to cut it up and slice it up. You want to build compelling reporting and dashboards on top of all of your disparate data sources. Well, how do you go from on-prem to cloud in that case? So the first thing we're going to do is we're going to put Apache Beam in here. And I'll talk a little bit about why Beam is a good choice. All right, so Beam is a very modern approach to data processing. It's very pipeline-centric. So as data comes into the kind of pipeline you create, you can apply a series of operations to it. And at any point in that pipeline, you can break out and dump things wherever you want to. But the idea is you can have a pipeline that starts with multiple data sources and funnel them through. And again, do things like in-flight aggregation. If there's time fields in there, you can start windowing some of that data. Basically, you can ETL that data into whatever format it takes. But what's really interesting about Apache Beam is that it unifies the model between batch processing and stream processing. So for example, today, the problem you might be solving is, I've got a bunch of databases, and I want to ETL them into some kind of cohesive data warehouse structure. And that might be a batch job. But tomorrow, you might say, I'm moving that to I'm going to start including streaming data sources. The great thing about Beam is that there's pretty much no change to your code. You effectively have to change the inputs to your code and say, this is a streaming source versus a batch source, and your code just works the same way at that point. Right? There's no real change. And that's a really powerful concept to work through. Beam is also really compelling because it's portable across a number of runtime environments. If you've already got a Yarn cluster running MapReduce or Spark on premise, Beam can sit right on top of Spark and run on top of Spark. Or it can actually run on top of Flink as well. And then when you want to get into the cloud environment, Beam can actually run in the cloud data flow service that Google offers. And I'll talk a little bit about that as well. And right now, as of today, actually, Beam supports building pipelines in Java or Python. So you have that ability to kind of mix and match depending on what makes sense for the skill set that your teams have. So Apache Beam is really interesting. If you kind of go way, way, way back into like the early 2000s, back when Google only wrote research papers and didn't really build kind of public-facing products around them, MapReduce is one of the first papers. I would say MapReduce and GFS, Google File System, were one of the first two papers that I think really came out and helped sort of kick off a whole host of other research at Google and a bunch of things that ultimately became part of the Hadoop ecosystem. So if you think about, again, Google File System, that was basically what became HDFS. The MapReduce paper is what became Hadoop and sort of, the follow-on between, MapReduce 1.0 and sort of the Yarn approach that came in Hadoop 2. But there's a strong lineage here for Apache Beam to build on top of. And in fact, over the last few years, Google has actually moved away from MapReduce internally into a number of other tools. Not just a new distributed storage approach, but also a distributed compute and processing approach. And the product of all those things over the last few years was something we called Cloud Data Flow. Cloud Data Flow came out, I think, maybe 18 months ago. And it was great. It's a very powerful tool. But what we saw was the need for adopting a more open source mindset because we want to see data flow be successful. We want to see, but even more than data flow, we want to see the idea of batch and stream processing become successful, right, from this unified code base. So what we did is we took data flow and we split the two things out. One is the service that we run for you, and the other is the SDK portion, which is what became Apache Beam. So now what you can do is you can write your pipelines in Apache Beam, fully open source under Apache, and then run them Spark, Flink, or on Dataflow. So you get a ton of portability for runtime, which is a really powerful concept. Because again, as you think about this world where you started from on-prem and you're slowly making your way into the cloud, you're not going to dump those original data sources. They just might be located in a different place. They might be running on GCP inside of things like Cloud SQL, Cloud Storage, Bigtable, Cloud Data Store, Cloud Spanner even. But you still want to use the same Beam pipelines. So instead of running them on-premise on top of a Spark or Flink cluster, you can actually run those Beam pipelines inside of Dataflow. So that's some of the history around that. Beam is actually, again, pretty cool. It has 4 main modes of operation. Very classically, a big batch job, the ability to do windowed batches if you want to do it by time or by data set sizes. You can also do things like streaming, again, out of the same code base, or streaming plus accumulation, which is a little bit in the weeds, so we won't spend a ton of time on it. So this is an example of a Beam pipeline. And on the left, I've got the batch version, and on the right, I've got the streaming version. And if you look, I only really had to change 3 lines of code to make this work. There's a little bit left out here. I've glazed over a handful of detail, but the important thing is that I went from a file-based input, which is a batch source, and a file-based output, to a streaming input and a streaming output, just by changing the inputs and outputs. Nothing else in the middle there had to change as far as the functionality goes. So when you think about running Beam pipelines and data flow, what are the advantages? Why would you even go down this road? And it's really important to understand that we take the idea of kind of managed services and managed infrastructure very seriously. We think it's a really critical component of how cloud should work and be built. And we want to see people be successful without having to sit there and fiddle with individual VMs and worry about scale up and scale down in a lot of these examples. So Dataflow lets you take a Beam pipeline, you push it to the Dataflow service, we scale up that pipeline and scale it down for you depending on what the input looks like. So if you're streaming data in and we see the volume of the stream start going up, we'll add more infrastructure. As we see the volume of the stream go down, we'll reduce the infrastructure. Just like the data set sizes, if you're doing in batch mode, if you see that you have a lot of data coming in, right? If you've selected a data source that's got a lot of data set size to it, we'll go ahead and give you a much larger cluster. And you have the ability to control sort of min and max there about how you want to handle it and how quickly you need the data back. But the important thing is that you don't have to go and actually provision and configure those virtual machines. We do all that for you. And then there's other great things like a built-in, kind of UI for monitoring and understanding your pipeline and debugging it. And then we do a bunch of other stuff on top of that as well. So two things that we've added recently, or that we've gone kind of more depth into recently, are templates and orchestration. With templates, you can actually define a series of inputs in your code that you want us to be able to templatize and parameterize at runtime. So instead of having to push your job every single time you want to run it with new parameters, you can stage the job once, tell us which parameters can be adjusted, and then you can launch this from either the UI or from the API just by passing in the new parameters every single time. And I'll just jump ahead for a second, but this is what it looks like to create a template, right? You've got to add a little bit of metadata into your code around all the parameters you're going to supply, and then we can go ahead and make it really easy to, again, run from a staging environment very, very quickly. If you kind of take that idea back to orchestration, what happens is you can start coming up with really compelling ways to sort of get your pipeline up and running, right? If you've got a templatized data flow job or a beam pipeline that you've staged in data flow, and you want to maybe kick off a job every time you get a pub sub notification, or you want to kick off a job every time a new log file is put into cloud storage, or certain rows are added to a Cloud SQL table, you can do that really easily. And you can orchestrate it through things like App Engine with cron or through Cloud Functions. And both of those can actually just go ahead and kick off a data flow job just for you. Again, without having to stage and upload jar files and push those things out. So it's a pretty compelling way to kind of run. On the template front, we have a couple of baked examples that are in the docs, like word count and cloud pub sub to BigQuery. Word count is, certainly the hello world of Apache VM or Dataflow, but actually cloud pub sub to BigQuery is a very common thing. We see people want to take streaming pipelines and go straight to BigQuery with just a little bit of transformation, and so that's an easy one that you can try out as well. All right, so that was the first one, kind of moving on-prem relational to cloud. And again, there's a ton of detail under the covers there. So if anybody has questions on this, I urge you to hit the mics or find me after the talk. I'm happy to walk you through some of the things I left out. So the next one is migrating Hadoop and Spark workloads to the cloud, right? That's a very popular one. Migrating the Hadoop and Spark part, to be totally honest with you, trivial, super easy. Right? You've already got jar files built. You might have some supporting libraries that have to go with them, but ultimately you just have to deploy those jobs on us, as opposed to pointing them to your local yarn master. That's not the hard part. The hard part is moving data, right? You've got gigabytes, petabytes of data stored in HDFS. How do you actually physically truck that over to us? Well, not physically, but how do you actually move that data over to us in a reasonable manner that, again, not just one time, because one time is easy. It's one time plus the ongoing transfer. And for that, we have a couple of great partners in Attunity and WANDisco, who are downstairs, by the way, on the first floor. They would love to talk to you more about this. But basically, they have software that you run on-premise that lets you facilitate the one-time transfer and the ongoing incremental transfer. And that's really important because if you kind of go back to what I said earlier, and this is a kind of a personal philosophy of mine, I hate telling people to move everything in one fell swoop. One fell swoop is not easy, right? It's pretty hard, and it's a lot of pain. You're better off trying to find an approach that lets you slowly make the transition and then lets you run really fast. If you try to do everything at once, things don't work well. You're much better off trying to find an approach that lets you start slow and keep running faster and faster and faster. And then over time, you can get rid of the on-premise HDFS cluster once you've made that transition and you've migrated data sources and ingest over to cloud as well. All right, so let's say we've done this process. We've got the batch transfer going. We've got the incremental transfer going. What does it look like when you're starting to run Cloud Data Proc, which is our managed Hadoop and Spark service? Data Proc is kind of cool, right? We do a lot of work, and this is kind of another core philosophy of Google Cloud. We do a lot of work to separate storage and compute. We want them to be able to scale independently. So instead of having you run HDFS on GCP, we tell you to run cloud storage, right? Cloud storage is always on, always available, all the nines you need on availability. The idea is that you do all your storage that you would typically have done in HDFS inside of cloud storage, and you spin up Cloud Data Proc clusters for Hadoop and Spark to actually do the compute aspect of your job. Cloud Data Proc lets you spin up compute jobs, or compute clusters, I should say, in about 90 seconds. And that's true of clusters that are anywhere from 10 nodes to 100 nodes to 1,000 nodes to even larger, right? And if you start to think about that, 1,000 nodes with 64 cores each, right, that's a lot of CPU power that you can get. Or if you're thinking of Spark from a RAM perspective, that's up to 416 gigs of RAM per instance that's running out there. So it's a pretty big number. You've got a lot of memory headroom to work with. And those clusters actually do spin up in about 90 seconds. It's probably on the order of like 70 to 90 seconds, but we kind of say 90 just in case there's a hiccup somewhere in there to give us a little bit of room, headroom. And Cloud Dataproc's got built-in kind of monitoring, logging, that sort of thing. And the best part is that you get to follow the same open source train. So if you're familiar with like the Apache Big Top project, it's kind of this idea where they sort of draw a line in the sand around all the versions of the software and call that a particular release. And it might be Hadoop 2x something, Spark 2 dot something, Pig, Hive, et cetera. That's a Big Top release. So we follow the Big Top release train, which is similar to what like Hortonworks does as well. In practice, Dataproc is actually kind of cool as well because you can resize clusters on the fly, including not just the number of nodes in there, but things like attached disks, or if you want to adjust the way the networking layout is on your cluster. We also have custom VMs. So if you want to skew higher on memory and lower on cores, for example, like in the case of Spark workloads, that's certainly possible. You just tell us the shape of the VM you want, and we'll use that for the worker pool. The third point, and this is what I think is the most compelling one about Dataproc, is the ability to use preemptible virtual machines. So just by a show of hands, who's heard of preemptibles in the room? OK, so a fair amount. So just real quick, preemptibles are super powerful. This is a machine that we can give you for up to 24 hours. Right after that, we can take it away at any time. But the idea is that it runs at 80% off list price. There's no limitation on configuration, right? It's the same exact VMs you get access to, except we can just we can preempt it basically within a 24-hour window. Now, if you think about how that maps back to your jobs, instead of running a job that takes 2 days on 100 nodes, why not run that job that takes less than a day on 200 nodes, or 500 nodes, or 1,000 nodes? Because you're running with a dramatically reduced cost, you can actually dramatically scale up your cluster size and get the compute job done that much faster. And on top of that, we actually have per minute billing, which means every minute you shave off that runtime means that much less you're spending. So it's an important kind of metric to start thinking about how to map your compute jobs around. And then on top of the other critical part of Dataproc is the ability to bootstrap a cluster, right? Because we know you're not just probably going to run MapReduce or Spark kind of in a vanilla form. You're probably going to want to tweak those things. So not only in tuning cluster parameters, but also the ability to install things like Kafka or Jupyter or Zookeeper or any other kind of open source packages. We have a bunch of pre-existing bootstrap templates to do all that stuff, and then we give you kind of easy instructions on how to bootstrap it with your own custom software. So if you've got custom jar files you want to spread across the cluster or custom applications that you've built, you can push those out pretty easily as well. The one thing to take away that I would urge you all to take away from this idea around Cloud Dataproc is this transition from being a cluster-centric approach to a very job-centric approach. Instead of saying, listen, I have a 100-node Hadoop cluster that everybody shares, and we're all going to try to fit into it and make sure we can get all our work done in a reasonable time, instead you shift your thinking. You sort of turn it on its head, and you say, what if every job could just have its own cluster? Right? What if every job could run as fast as they wanted to and get done super quickly? What kind of impact could that have on your ability to use your data in a meaningful way? So that's the idea with Cloud Dataproc. We want people to move away from this notion of having to run a single large stateful cluster all the time, and instead make the move to a very job-centric approach. Because now you're letting everybody scale themselves individually. And again, if you start taking advantage of things like preemptible VMs, custom VM sizing, you're getting kind of the most optimal deployment, the most optimal compute cluster for the needs of that job. And that's really important. And that has a lot of impact, again, on what you could have done in the past on-prem with sort of a limited amount of resources versus an incredibly elastic set of infrastructure inside of a cloud. All right, so that was the second one. The third one is this idea of exposing on-prem data to cloud applications. Right? You want the cloud applications, you want the part that responds to like customer requests, you want the parts that interact with mobile devices or back those services, you want those to be as responsive and scalable as possible. So very often we see this where people want to deploy applications, their developers want to be able to work with new infrastructure, so they'll use cloud to deploy applications into, but they still need access to data that's on-prem. So how do we facilitate that? All right, so here's the diagram, and I'll go through this in depth a little bit. So the first one is you've got to get the network infrastructure spun up, right? It's not just about having good connectivity with all your applications talking to each other in the cloud or all your stuff that's sitting on-prem talking to each other. You've got to facilitate the connection between them. That's the first most important step. And we do that with two critical components. The first is interconnect, right? Cloud interconnect lets basically us, Google and y'all, find a common third-party partner like an Equinix or an L3 and facilitate low latency IP connectivity, IPv4 connectivity. That's the first most important step because we want to maximize the bandwidth between us. We don't want the network to be the bottleneck if we're trying to front on-premise infrastructure, on-premise data. So we can get up to like 10 gig links. Great. So we've solved the latency problem once we do all that. What's the next important part? Securing that line, right? Because that is a public IPv4 connectivity. We can't just leave that out in the open because then we've got, anybody can look at that data passing through there. And we want to secure that as best as possible and make sure the only traffic that we want to go through that pipe is ours yours and ours alone. So we do that with VPN, right? We have Cloud VPN on our side, and then we have a VPN gateway on your side. And we just have to get those two talking to each other. And it's a pretty simple step. We do this via the API, via the G-Cloud tool, deployment manager, whatever the case may be. It's a very simple step to just spin up the VPN gateway on our side and have it talk to yours. Once you've done that, we've got a secure, low latency link between us. If you skip this step, everything else kind of falls apart. So this is critical and it's important. And it's kind of useful in a lot of other scenarios as well. So it's important to kind of explore this as you're trying to make this move into GCP in general. But after networking, the next thing we want to do is front on-premise data. I like using Kubernetes because it lets me write applications in one place and deploy them somewhere else on any Kubernetes cluster. So in this example, I use Kubernetes. It could really be anything. But the idea is that we've secured the link. We want to give new applications access to this data, but we really don't want to give them like direct access to the data. Let them go through a CRED API. Let those connections be audited, right? Let those queries and jobs be audited. Let them get logged very well. Basically, give them a modern API on top of, on-prem data infrastructure that might be older, might be newer, it doesn't matter, but give them a consistent API to work off of. Let that front your data sources. And it's important, to think about that because one, it certainly follows like a modern development path if you kind of take this REST API approach to the world. But also, as I said earlier, it gives you an opportunity to monitor very closely how that data is being used and where you can make optimizations. If you give people sort of direct access to the database, you might not have as much granular control as you want to have, or you might be punting the access control problem back to a database, maybe to a system that can't support it. So it's kind of cleaner separation to have this little API, this thin layer that sits, a little shim that sits between the database and new applications. And then the second thing, or the next thing is spinning up the cloud application infrastructure. I picked Container Engine here, but it could really be anything. It could be App Engine. It could be applications running on Compute Engine. Doesn't matter. But the idea is that let us handle the scale part of the problem. Use our L7 load balancer, right, to get one global IP that works everywhere. Let that be the thing you give out to DNS infrastructure. Send all your traffic to those applications, and let us manage the scale out aspect, and then send traffic back when we need to get access to that on-prem infrastructure, that on-prem data. Right. The last one, and this is sort of the optional step, it just depends. If you're inside of Kubernetes and you're running Kubernetes in both places, you might not really need the service discovery piece with something like Console. Very often, the diagram is not this simplistic. It's usually a litany of applications on both sides of the equation that may come and go, and we may shift the approach that we're taking. So it is nice to have a good cross-cluster service discovery mechanism, and it's hard to beat Console, right? It works pretty well. It's got a pretty solid following. So I like to go down this road pretty often. All right, so that was the fronting, kind of on-prem data. The last one I want to come through is scaling to meet IoT workloads, right? This goes back to our kind of connected light bulb scenario. You've got all these little devices that are generating a ton of data that are probably going to like a local gateway or like, if you're familiar with like the Philips Hue system, they have light bulbs and they have kind of the bridge, and the bridge is what communicates out from the home. So in that sort of a scenario, this is what it might look like. We might have the gateway communicating with a REST API that's running on App Engine. Maybe you've got cloud endpoints, maybe you don't in front of it, but you're going to stream data out from all those bulbs, and you want to capture all that data. But you want to make sure, like we've kind of called out in the bottom, that on-premise infrastructure still has access to that data. You don't want to lock it out, because you're locking out your ability for everyone to take advantage of it. So what does that really, how do we do that? Part of the reason you want to go down this road, again, it kind of comes back to the whole on-prem challenge piece, which is you've maxed out resources, you might not have any more headroom, and it takes too long, even if you were able to funnel all that data through, because of just generic compute limitations. So you want to try to find the best approach here that, again, lets you take advantage of all the elasticity and the scalability on the cloud side, but doesn't cut off people from learning from that data as quickly as possible. So the first most critical component here is PubSub. How many of you guys have heard of PubSub already today? Oh, everybody. So I can just skip this slide, right? I'll talk about this really quickly. Think of PubSub as a completely managed, forget the diagram, right? It is a completely managed message delivery mechanism, okay? We can create things like topics and subscriptions. Subscriptions can be pull or push-based, depending on what the sort of downstream endpoint is. And if you think about messages coming in to infrastructure, we can actually split those messages and have multiple different mechanisms handle them. So you might have one mechanism that's sitting there saying, I'm going to aggregate all this data in flight and I'll write it to a database. Another one might say, I'm going to ETL this data and write it to a data warehouse. And a third one might say, I'm just going to pipe these things back out to another PubSub topic and send messages to another application. You can do all that with PubSub with, I think, about 3 or 4 G cloud commands, right? Create the topic, create a series of subscriptions. Each one of them gets their own copy of the message. So it's a pretty powerful piece. And then on top of that, we have other kind of cool, interesting features like labeling. You can auto-expire certain things by default. I think by default in a subscription, messages expire in about 7 days. If you want to tune that, you can have the ability to tune that as well. And in fact, as of, I think, a few months ago, PubSub actually connects up to Kafka. So if you've got a Kafka cluster running on-premise, you can actually hook up to Kafka for ingest and as an output source as well. So you can actually use that as a mechanism to get data in and out. And we do this very often with customers. PubSub has a really easy-to-use REST API. That means there are a ton of tools, like the enterprise service bus tools of the world that are really critical to your infrastructure. Those can actually just access a REST endpoint as long as you set them up correctly. So they're actually going and hitting PubSub to get information back out in a way that's good and sort of scalable for them as well. All right, so the idea here is that we want to reduce time to insight. So first, right, we're going to have events coming in off those light bulbs. They're going to hit the IoT gateway. The IoT gateway will send it to the API, and the API will start this chain of events. So what will first happen is those events get pushed individually to PubSub as individual messages. Then we'll have an Apache Beam pipeline that's running inside of Dataflow take in every bit of those streaming messages. And because it's in Dataflow, that Beam pipeline can grow or scale as much as it needs to. And we can shard and reshard that data in flight so that we're not dropping anything on the floor. And that Dataflow job is actually going to do a split, right? It's going to write things out into 2 places. The first thing it'll do is it'll do maybe a little bit of light ETL transformation and kick that stuff over to BigQuery. If you want to do kind of SQL on an ad hoc or exploratory basis later on, or if we want to build a compelling visualization or report out of that data. And then what we might also do is write the very raw kind of time series and use Bigtable for that. The idea of splitting these things out is really just by use case, right? We might want to do kind of business analysis in BigQuery. We might want to use the Bigtable kind of storage view, the time series view, as a source for like longer-term machine learning or experimental use cases. So it's nice to have the option of not throwing anything away, not sort of over-normalizing the data. We have got a lot of options. Storage is relatively cheap these days. Let's write it out in 2 places, and we can take advantage of that. And then the last step is the Dataflow job will actually do a third output and push things like aggregates, right? You might not need to know every single event that every single light bulb generated from every single home that they're deployed in. What you might want to do is roll up maybe a home and say, hey, for this house, we saw the bulbs transition from state to state maybe n times, and wrap that up as a single message, one single piece of data, like a single piece of JSON, and then publish that to PubSub. And then you can have other tools like the on-premise infrastructure read from that PubSub topic and just get the aggregates out. So now you can start to take advantage of the idea that, listen, we're going to offload all the scale and ingest part of this problem to cloud, but still have access to the data, pull it back out, and learn something from it. And it may go back into other on-premise applications or tools that are maybe internal-facing or even external-facing. But it gives you the ability to kind of assess what's happening in these houses on a regular basis without losing any access. All right, so we kind of went through 4 scenarios. We burned through it a little bit quickly because I do talk fast. I apologize. But I'm happy to take questions. I do want to come through that. As you think about how to get started here, right, there's a lot of detail. There's a lot of little things. If you take nothing else away from today, don't hesitate to really go down the path of understanding network connectivity. If you don't get the network part of it right, everything goes real slow. And it's really hard to take advantage of all the scale when something over here can run really, really fast, and you might have enough infrastructure that runs fast, but the pipe between the two is slow, or it's, you're dropping packets, or it's not secure, right? That's a critical part. The network is very, very important as you think about it. And then, find a workload that needs scale. I'm pretty positive that every single one of you could come, stand up and tell me at least one workload that you've run into that is running out of scale in the current approach, right? You need more headroom to go faster. So then you've got to think about, how do we actually make that move? Do we have to migrate data? Do we have to migrate applications? Do we have to point data that's coming in to cloud and have it go through that approach? But you've got to find something that makes sense and figure out what your migration strategy is going to look like. And then you want to test and scale it out, and then figure out which metrics or which kind of KPIs are really important to understand and say, this is successful or not successful, or we have to iterate. And then the last thing is really, frankly, be agile. Be open to shifting the approach and finding new ways to do it, but use mechanisms that are really easy to iterate around. Things like PubSub and cloud storage are super easy to work with because you can kind of put data in a pretty generic way, and then you have a lot of capabilities to move things around and reformat what those look like. All right, a couple of other sessions I would suggest you guys consider looking into as you're here today and tomorrow. So one is open source data processing on GCP. It's going to go into depth on Beam and Hadoop and Spark running on Google Cloud. The next one is migrating data warehouse to Google BigQuery. Right, that's a really important one. That's it dovetails right on the first example we talked about, migrating on-prem relational to cloud data warehouse. And then the last one is large-scale data ingest. Right, this is true for applications, mobile devices, IoT, what have you. If you have a lot of data coming in, how do you do it, again, in depth on GCP?